In this video we're going to look at ratios, and you might ask, why ratios? Why do I need to know about ratios? Why would I use them? Well, if you're in an art class and you're trying to make a specific color of purple, you might do this as a ratio. To get this particular purple, this has a little bit more red in it. So if I'm looking at my ratio of red to blue, I might use 3 parts red and 2 parts blue. So the ratio is 3 to 2. For this shade, it's a little bit more blue. So maybe my red is only 1 can, and my blue, I used 2 cans. Or in this one, maybe I use red, 1 can of red, and 3 cans of blue. That's a ratio. That's an example of where you might use a ratio, a proportion, a piece of one part of one color, 2 parts of another to get the shade that you want, mixing colors. And that's what they do in the paint store. If you notice, you get the little label. It has how many drops of each color. That's a ratio. All right, let's try to create a ratio here. I want to know the ratio. Let me pick a brighter color. I want to know the ratio of squares to circles. Okay? So let's count my squares. 1, 2, 3. So my squares are 3 and my circles are 1, 2, 3, 4, 5, 6. 3 to 6. I can reduce this fraction and my ratio would be 1 to 2. Another way to write my ratio is 3 to 6 or 1 to 2. These are different ways that you might see ratios. You could also see them as proportions. Now this is ratio squares to circles. What if I switched it up and changed it to ratio of circles to squares? Well, then I'd count my circles first. I have 6 circles for every 3 squares. Or, simplified is 2. So I can write this as 6 to 3 or 2 to 1. Those are different examples of ratios. Let's look at this example. Which choice shows the ratio as the same? Dolls to cameras. I have 2 dolls. I have 3 cameras. Those aren't equivalent. Let's look. 3 dolls, 2 cameras. Not the same ratio. 1 doll, 2 cameras. Still not the same. 4 dolls to 2 cameras. Still not the same. 2 dolls to 4 cameras. Okay, so they don't match up. You say, which one would be the same? Well, now they want us to really look at which of these are the same ratios. Is 2 to 3 the same as 3 to 2? Is 2 to 3 the same as 3 to 2? How about, is 2 to 3 the same as 1 to 2? Nope, I can't turn 2 to 3 into 1 to 2. How about, can I turn 3 to 2 into 4 to 2? Let's look at some skills of how we might be able to solve this problem. We're going to come back to this one. To do equivalent ratios, we need to find different ways to find equivalent. So that's what we're going to do here. We have the fraction 2 over 6. And I want to know, of these fractions down here, which ones are equivalent or equal. So there's several ways to do this. The first way, let me take one fraction, move it up here, 3 over 9 and 2 over 6. One way is to reduce each of the fractions. And I can reduce 2 over 6. Well, both of these numbers are divisible by 2. So when I divide by 2, I get 1 over 3. And over here, 3 over 9, they're both divisible by 3. So when I divide them by 3 to simplify or reduce the fraction, I get 1 over 3. 1 over 3 is equal to 1 over 3. Therefore, 2 over 6 is equivalent or equal to 3 over 9. That's one way to do it. Now, let's look at the next one. Let's see 2 over 6 compared to 4 over 12. Another way I could do this is, I know 2 times 2 gives me 4. So 2 times 2 gives me 4. If I multiply the bottom by 2, do I get 12? Yes. So if I can take the top number and the bottom number and multiply them by the same number and get my new fraction, they are equivalent. That's another way to do it. The third way is product by product. And we're going to look at the fraction 2 over 6, our original fraction up here, and is it equivalent to 10 over 30, which is this fraction here. So we're going to do bottom up. 6 times 10 is 60. 30 times 2 is 60. Therefore, they're equal or equivalent. I'd like you to decide, do you like reducing fractions, seeing if there's a common product, or doing bottoms up to check for equivalent? Use whichever method you like to check the final one. 2 over 6, 6 over 12. Are they equivalent? Take a moment to check. My favorite is bottoms up, so that's the way I'm going to do this one. So 6 times 6 is 36. 12 times 2 is 24. Does 24 equal 36? No, so they're not equivalent. Those are all the different ways that you can find equivalent or equal fractions, ratios. Now, let's take another example for a minute because those were all in fractions. So if I have the ratio 1 to 3 and I want to know if it's equivalent to 2 over 6, I can do the same method. Or I can convert this to a fraction. 1 over 3, 2 over 6. Okay? And I can reduce my fractions. I can do product. I can see if there's a common multiplier. Let's check and see if there's a common multiplier. How do I get from 1 to 2? I multiply by 2. Well, when I multiply 3 by 2, do I get 6? Yes. So these are equal ratios. Let's look at another one. Let's say it was 1 to 3, and it was 4 to 8. 1 to 4, I multiply by 4. When I multiply 3 by 4, do I get 8? No. So it's not an equivalent ratio. Now that we know this, let's go back to the doll problem, the doll and the camera. So this is the ratio 2 to 3, which I could also write as 2 over 3, we now know. Okay? 2 over 3, we know, is not equivalent to 3 over 2. If I do product, that's 9, 4. 4 does not equal 9. Looking at this, do you see an equivalent fraction? We have 2 over 3, 3 over 2, 1 over 2, 4 over 2, and 2 over 4. Do you see equivalent fractions? If you said yes and said C and E are equivalent, you would be correct. I can go from 1/2 to 2/4. If I reduce the fraction 2 over 4, I get 1/2, which is the same as letter C. So C and E are equivalent. They're the same ratio. Let's take ratios a step further. Pizza slices to girls. So pizza is the first item, girls is the second. So the first item is my numerator, the second item is my denominator. There are 2 pieces of pizza, 3 girls. But now they want 33 girls. Where does girls go? Girls goes here. How do I go from 3 to 33? I multiply by 11. What I do to the bottom, I must do to the top. I'm creating an equivalent fraction. 2 times 11 is 22. So if there are 33 girls, you need 22 slices of pizza. Now, if we did the product up, we would have 2 over 3 equals x over 33. So 2 times 33 is 66. Now we're going to do a little bit of algebra. 3 times x is 3x. I can't leave my problem like this. I need to find x. So 3 times what number gives me 66? Now if I show my work to undo multiplication, I need to divide. And 33 divided by 3 would give me 22. That's another way to solve this problem. Hopefully you understand the importance of ratios, different ways to write ratios, and how to use a ratio to find a missing piece. Good luck.